think we talked about a lot of different examples of Python and some applications of it. So I'll do a very quick review with you guys as well. So yeah, like if you guys already know Python right now, you can just maybe you can look up some of these practice problems that and solutions that I've given in my playlist here. You know, I've given a bunch of Python problems, you know, for some students. Maybe if you want to take a stab at it, like, you know, try to figure out some of these questions. You know, I'll walk through a question. You know, here, these are some of the questions, you know, like assign the fifth list to a variable, print the fifth element in a list. How would you, you know, do this? How would you print out the last element of a list? You know, just very simple questions. So far, for some of you guys who might know Python, depending on it, you know, how do you sum up the values as well? And if you don't, I have some explanations there. So yeah, okay. So if you guys have already have some idea, you can try this out. No worries. Okay, but now I want to show you, if you look at Google and then Colab, if you type this in, then you can click here, welcome to Collaboratory. You can just click, like, there's a button that's a cancel. You can just click this button here, here, cancel. Then what is a collaboratory? Okay, it has all this stuff here. It's, you know, free access, easy sharing. Colab can make your work easier. Watch this introduction or get started below. So you can run code here. So what we can do is we can just click plus code here, and then we can add code as much as possible and collaborate. Or we can also add a text field, where this would be text, where we can say, hi there, everyone. This is Getting Started with AI by Sanya. And then what you can do is you can see how this looks as well. This is text like this. You can click it, you can edit it as well. You can make it all bold. You can increase the font as well. You guys see that? So here, like if we do a very quick run through of Python, so you can see, like, we can have print statements in Python from this link, guys. Again, I'll share the link here. We can print hello world here. We could also have variables and data types. We have numbers, like, you know, integers, floats, doubles, scientific notation. So here, so you can see hello world is an example with a smiley face. You can print out example, you know, you can have print statements. You can have variables. So this can be like a variable. So we can have a variable like x, for instance, right? X equals 3, which is an integer. And then we can say x is 3. That way we can try x equals 2.345, some random number, which is a float or a double. So we can see x here. We can also see the type of x, which is an integer. We can have x, we can override x. That means we can replace x here and then say type of x. So what you'll notice is that any time a cell has run, you will see a number next to it. That means that you've run the cell. So if I have another example, like a equals, like if this is a, but if I try to call a here, it's going to say a is not defined. And why do you think it's not defined, this variable a? Why do you guys think it's not defined? That's a good point, but like, see, I can call x in another block of code. Very good. You're thinking in the right direction, though. What do you not see next to the block of code where a equals -10243? What do you not see next to it in that cell? Like, what do you not notice in this cell here? Close, but okay, you see this. So what do you guys see about this cell, this cell, this cell, all these cells here? What do you guys notice that they have? An output, yes. And the output comes it comes because when you run a cell and Python, it shows in Python, this is a lab. This is like a Jupyter notebook, but everybody can kind of work on it. I could share it with you guys as well. So what this is basically this, the problem here is that what this is not run. That's the thing. I have not run it. When I run this, it's going to have, it's then going to have a number next to it. And now when I run this, it will be found. Do you guys see that? So it's not stored almost. It's almost like I have all this stuff, but I haven't pushed it anywhere and it's not being used, right? So if you ask for it, it's like it's not even, it's like you've written all this work, it's not been published, nothing's been happening with it. So it's kind of like that idea. You've all this work done, but you haven't really pushed or done anything with it. So that's the thing about declaring variables. You can even do divisions with variables as well. Like you can do mathematical operations. You can do, if you have these numbers, you can have addition, and I can print C. And this is how you can print statements with variables. In the core classes, we'll actually go more slowly over these concepts. You know, I can print C is, I can put the statement here and a print statement. And that I could have C is, this is multiplication. And that I could have C equals, you can see multiple statements. So this is A. Oh, hi there. I have a little, my sister's cat is here, like wanting some little attention. Cats are very difficult to know because it can be very unpredictable. Oh, looks like the cat is coming here. Okay, anyways, guys, that's the cat. I don't know if the cat will come on the video. So, oh, the cat's gone. Anyways, but basically, so you have these values A and B. I can print A is, and I can have A. That's how you can have a statement B is, and then I could have B. A is 3, B is 2.5. If C equals A plus B, then C is 5.5. That's what this is saying here. And I can override the values. C equals A times B. So if A is 3 and B is 2.5, so then C is 7.5 here. This is multiplication. And then this is division, where if, you know, 3 divided by 2.5 is 1.2. So you can sort of see, you can do all sorts of operations and you can assign them to variables. So now in this last case, this is what C is. C is 1.2. You can also have strings in single or double quotes as well. So you can also override variables. You can have true and false statements here. And then the way you can see, like if we have this here, if we do type, this tells you the type of variable. Type of A here right now is the type. So if I run this, then I run this, it's a string. So the order of these tells you the order of execution. So this is 1, 2, 3, 4. So if I run this again, so you see the most recent thing I've run is 16. You see like the cell is 16. You see the cell number is 16. Right? So if I run this again, this first line, for instance, or let's say I run this one will change to 17. So what it is it's sort of like a way for you to keep track of what you've done in the notebook. It's not really recommended to do it. Like you should technically run every cell in a notebook, like from top to bottom usually. But what happens when you're coding is that you might come up with some idea. You might be down here and you might come up with some idea like for something above, right? And then you might be like, oh, wait, let me just do this operation. And it may not be in order necessarily. So this thing kind of helps you evaluate like where you are. So this will kind of tell you. So you typically go 1, then you look for, okay, there's no 2 here. What's the next smallest number? I did this one, which is 3, then 4, then 6, 7, 8. Okay, there's no 10, there's no 9 here, but this is 10. Anytime you run a cell, the counter updates. It's almost like it's helping you track how you've gone through the document. So the way to go through this is to just basically see, like, and now if I get rid of this, there's no more 1. It's now 18. So the way you know what you've run is to kind of go through these cells from smallest value to the largest value. Largest value means it's the most recent. Does that make sense? So it might not be continuous. Like you can have 18 now. Now we don't even have any 2 anymore. We have 3, 4. Those are the smallest. We don't have any 5. We have a 6, 7, 8. Then I'm scanning it for the next ones. 10, 11, 15, 16, no, 11. Then I think I jumped here. Then I jumped here and here. You see that? Like, so from 11, I jumped to this statement here. Then I jumped to this statement and then this statement here. So you can sort of track it. And why? Because here I'm overriding A. A was 3 here, then I'm overriding A, then A. So just something to know is that like the numbers kind of tell you the bigger the number, the last it was run. Sorry? Okay, anybody have any questions on that? Then we also have like, so if I run this again now, I can see that the type, this will be 19 because the most recent one was like an 18. So this will be like a 19 here. And then I can also say this was run. So I can do type of A and it'll be bool, which is short for Boolean. Boolean, I think of like boolier, like it can be true or false. This is a list here. This holds a set of values. You can hold any types of items in it, like integers. This is a list. This is a tuple, and then this is a set. These are just different variables. So yeah, these are just ways to sort of navigate through. Get a variable be null. Okay, that's a good question. We can have. You can't have a null value. You can have a none type. You can have none. It just has no value. That can be the case. You can have a none value, and this can be equivalent of a null. So does that answer your question? You can have a none, and then you could have type of val, and it will be none type. That's equivalent of a null.
Yeah, that makes sense. Thank you.
Okay, awesome. Thanks.